Okay, a wonderful, in fact, really powerful application of inversely proportional or inverse proportionality actually is with light. You take light for granted. Light is just light. It goes and whatever. But in fact, light is really, really an amazing object or amazing thing to study. And in fact, physicists study this all the time. And in fact, the reason why you can see me is because of light and the passing of light and so forth. But if you just think of sort of raw light, so imagine just a beam of light. Well, that sort of, you can sort of see that here. You can see, ooh, look at that. There's the beam of light. You see, that light actually is traveling, and the illumination that is given, of course, drops as you go further and further from the subject. Okay, the light actually drops. And it turns out, and this is real, that it drops inversely proportional to the square. So the illumination, I have it here, the illumination produced by a light source varies inversely as the square of the distance from that source. So think about it for a second. The further you are from a light source, the less bright the light looks. And the closer you are to the light source, the more bright the light looks. And it turns out those things are inversely proportional to the square. So in fact, if you know a certain illumination, so you have an illumination, that's going to be proportional to the distance squared, inversely proportional to the distance squared. So how would I write that down? I would say that the illumination, I'll call that I for illumination, is inversely proportional, so 1 over, the distance squared. So the further away you are, as this number gets bigger, this whole thing gets smaller, so illumination gets smaller. The closer you become, so then this number actually gets smaller, then this whole fraction gets larger, the more illumination. And in fact, this law actually captures the spirit of what happens with light. So what this means is I equals some constant divided by the distance squared. Now, suppose that for this light source, for example, so here it is again, you can see it, there it is. For this light source, suppose that at 5 meters, the illumination is 70 candela. That's the way you measure illumination. So that means that when we have a distance of 5 meters, the illumination is 70 candela. Well, can I then find the constant? I can find the constant because I would say that 70 would equal this constant divided by 5 squared, which is 25. And so what I see here is that the constant would just be 25 times 70. And you can multiply that out. In fact, if you want me to, I can do that really fast for you. 25 times 70 equals 1,750. And so what that means is that for this particular light source, of course, different light sources will have different constants, but for this particular light source, the illumination is equal to 1,750, all divided by d squared. So now knowing this, here's a question. What is the illumination at a distance of 12 meters? Well, how would I find that out? Well, what I would do is I would put in 12 for the distance and see what the illumination is. And so that illumination would equal 1,750 divided by 12 squared, which is 144. And so what would that equal? Well, let's try that really fast. So I take 1,750 and divide it by 144, and that would equal around 12.15727 stuff candela. And so in fact that's the illumination. And you can see that it's a dramatic drop from the given information, which at 5 meters we had 70 candela, and then at 12 meters we're actually going to have 12.15, a dramatic decrease in the illumination as you go further and further out. Okay, so that takes care of an inverse proportionality. In fact, this is an inverse squared proportionality, and all from lights. And this is a real-world example. And of course, this begs the bonus question. So now it's time for that bonus question. And the bonus question, of course, is, where were you when the lights went out? Okay, are you scared? I hope you're not scared about math, just scared about me, which you have a right to be. All right, I'll see you at the next lecture. Good night.